Hello, everybody. Today I will be talking about hashing and hash functions. What is a hashing? Hashing is a technique used to uniquely identify objects among a group of similar items. It is widely used in data structures and security applications. For examples, in universities, students are assigned unique roll numbers, which makes it easy to retrieve their information effectively. Similarly, in computing, hashing helps store and retrieve data quickly. So let me go to give me the example. Like here is the table of student informations where this image represent student informations storage, where each student is identified by a unique roll numbers and other details such as name, marks, and course are stored. So what is the hashing concept in the image then? Now, the roll number act as the key in a hash table, and the address is the computed hashed value index where the corresponding strain data is stored. So in the right table, and say the right side table, it represents the actual data which is stored at the computed, I will say computed had address. Uh, Here, other is what is a hash functions. Here, here how it is how the table use the hash functions. So we can see that hash functions will helps to maps roll numbers to an address using here is the formula like hfx is equal to x mod t, where mode operations for it operations for the indexing. So what is the x? X is a roll number, and t is the size of hash table, and the result is the index where the add data is stored. This is a hash function. So we are going to discuss about the presentations of characteristics of good hash functions. What is the benefits of having good hash function? So it is deterministics, which means the same input always produce the same as hash. And the other is it is fast computations, like it should compute quickly even for large databases, and is distributed uniformly, like it should always distributed data across hash table. And also other is pre-maze resistance, like it should be difficult to reverse the hash back to the original input. The other is collision resistance, like two different inputs should not produce the same hash. And the last one is avalanche effects, where small changes in input can cause drastic output changes, like when there is a small change in input that should result in significantly different hash value. Because of these characteristics, will ensure efficiencies and security in applications like databases and cryptography. So, what will happen if there is a collisions, like has collisions, and how can we handle that types of collision? At first, what is a collisions? A collision occurs when two different input produce the same hash value. Like from examples, we can see here, like when if like two students roll number generate the same had address, then it results in the collisions. That is what is collisions, and it will be like difficult to know which one is the right persons because it is giving the same value. So, to handle such type of collisions, there are collision handling techniques like chaining. So, for chaining, I will say its cell in the hash table will point to the linked list of items with the same hash, which means we use a linked list as its index. Then other is open addressing. Like all elements are stored within the hash table itself using a technique like linear probing and the quadratic probing, which means we will store the next available space in the table. So, what is the time complexity of hashing? When the from we can take from the above example, like if hashing works perfectly fine, if we can retrieve student data in a constant, then we can retrieve the data in a constant time. Like if there is no collisions, then it will be like big O of one, which is the best case and the constant. Like which can where it says when the hash function distribute evenly lookup and insert operations, it will take a constant time. So average also it will most operations remains the constant time, and in well designed hash tables. So other and the time complexity for worst case, like when the student maps to the same address, like when the collision happens, then it will be a linear time. Like when collisions are high and all elements are stored in the same index, that's so example is like bad hash functions will lead to the clusterings. That is a worst time complexity. So other we are going to discuss about is real world application, why we use uh, hashing in real life. Hashing is widely used in various fields like data integrity checks, like hashing verifies file integrity to detect corruptions. And other is it also ensure the passports are securely stored, like it provides the hash passport, and it will be very hard to encrypt those kind of passports. And also it helps in blockchain and cryptocurrencies, like it will secure transactions in the bitcoins. And also it is effective efficient in searching, like hash tables speeds of data and retrievals in databases and catching mechanisms. That's how we use hash tables hashing in real life in the application. Despite of its benefits, there are some limitations, like table size constraints, like the size of hash table will also sometimes impacts in the performance. And the hash collisions, like even like well designed functions can produce collisions. And integer overflow, like some system may not support large hash values, but to minimize this like from happening, we use collision resolution strategies and also dynamic resizing of hash tables. So what we can learn in the conclusion is in summary, hashing is a fundamental concept in computing, which will ensure efficiency, security, and data integrity. And also we can retrieve the data very fast. um, the choice of hash functions depend on applications, whether it's for data security like cryptographic, or storage optimization like non-cryptographic. Proper collision handling techniques helps to maintain it will help to maintain the efficiency. So why we use hashing is because understanding hashing helps in designing effective log algorithms, and also it helps to secure the systems. That's why we the hashing is very important.